We love you, but we don't want you to be here. Okay, all right. Let's finish this up with triangle area. So from geometry, you already know how to do the area of a triangle. You learned a formula. Okay, does anybody remember what that is? You took the SATs, probably on that. What's the area of a triangle? Yep, 1/2 base times height. Okay, so the area is 1/2 BH. Okay, unfortunately, that only works if a triangle is a right triangle. So we have to have a different formula. All right, so there you go. But it only works with a right angle. So we need a different formula to handle all of the oblique triangles that we now have, because most triangles in life are not going to be right triangles. There's going to be something, it's not going to be straight or whatever. So we have a second formula that also will find area, and it's 1/2 BC, okay, because we don't necessarily have a height anymore, but we have C, and then sine angle A. So it's similar, 1/2 base times height, 1/2 B times C, but then because it's not a right angle, we need sine of A. What if you switched some of the things around? What if you had A and B instead of B and C? Well, then your sine is going to be of a different angle, and it's going to be of sine C. It's one of everything. Basically, if you have little a and little b, then it's capital C. Little b, little c, it's capital A. So the third option would be if you had A and C, both small, and then this would be capital B. So those are the three versions you could use. You can use it from any corner of the triangle, and it works for an oblique triangle. Okay, so something maybe like this, where it doesn't have any right angles, and you've got A and B and C. But again, it works from any corner. You pick the corner, and you can find the area. So here's an example of using that. So in other words, if you have a corner, you can find the area. And so if I give you A, B, and C as your sides, and I tell you 102, okay, well now you've got your corner, and so you should be able, if I also give you 112 and 52, all right, and I say the directions are find the area. All right, well, you're going to take the corner that you have, and the formula version that you're going to use, because you have capital B, you'll be using 1/2 AC sine B. Okay, that'll be the version that you use. Okay, which means we're missing some of the stuff we need. So we're going to have to use our laws to find the missing parts. Okay, what do I'm given a pair. So because I have a pair to start, I'll start with the law of sines to help me find what I'm missing. So you guys are pretty good at that now. So we've got sine 102 over 112 equals sine of C over 52. Okay, I've already done all the cross multiplication in my work. So just to save us time, it is 27 degrees. All right, if we know that that's 27 degrees, we can fill that in, which means we can also fill in angle A. And angle A is 51. Okay, now that we have all of our angles, we could choose any angle to find our area from. We don't necessarily have to do the one that's using angle B just because we were given angle B. Now that we've got all three, we may want to choose a different angle. Now it looks to me like angle A might be the better option, because in order to do an area, I need one angle and I need the opposite sides from that. Okay, so I need, and I don't have angle A, or I don't have side A right now, so I might as well switch and use a different formula. So I'm going to switch formulas, which is totally fine, and I'm going to use BC sine capital A. I'm going to do that one instead. Okay, you can pick the corner that you want to find the area from. So that would be 1/2 times 112 times 52 times the sine of 51. So I'm switching to a different corner. That works out to be 2,263 square units of area. I don't know if it's square feet or square meters or square centimeters, so it's square something. So feel free to switch corners, okay, if you like. Okay, this area formula on triangles helps us to do other shapes too. So here's another shape we're going to work on. Find the area of a decagon with radius 14. All right, now you know probably what a pentagon and a hexagon and even an octagon. What's the most common octagon you see every day? Stop sign, okay? So what's a decagon? 10 sides, okay? But it's all even. It's not like it's weirdly shaped. It's a nice, even decagon. So I need you to imagine a 10-sided figure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to draw it perfectly. Inside of a decagon are 10 perfect triangles. I'm just going to draw one of them. Okay? Inside of an octagon are 8 perfect triangles. Inside of a hexagon are 6 perfect triangles. So inside of my decagon are 10 perfect triangles. They come from the center, so you find your center, and then you make your triangle. All right, I'm just going to focus on one of the triangles, because if I can find the area of one triangle, then I know the area of all 10 triangles. And so we'll start with just one triangle. Now we know it has radius 14. What that means is that these two sides are both 14. It does not mean the outer edge of the triangle is 14, the one that would be on the outside of the hexagon. It just means that the two arms coming from the center, those are radius, are both 14. The other thing we know about a decagon is how many degrees are in the center of this triangle right here. Altogether, how many degrees would be around the center of a decagon? 360. Okay? I need to divide that up evenly among the 10 different triangles that are all coming from the radius. So how much should each triangle be?
36.
Perfect. All right, so this triangle has 36 degrees right in the center. And then maybe you want to call it A, B, and put C in the center. So that triangle, I've got A, B, and C to be 36. And then we have A, B, and C, both A and B are 14. That combination right now, where you've got one angle and two of the different legs, that's what you need to find the area of that single triangle. So we'll set up our area then to be 1/2 14 times 14 times sine 36. Okay, I've worked that out already. That comes out to be 57.603 square units. But that's just one triangle. Okay, one triangle is 57,603. So how much is the area of the entire decagon? Well, how many of those triangles are there? 10 exactly equal triangles. All of them are exactly the same. And so since I have 10 of them, all I have to do is multiply my area by 10 and to find the decagon area. Decagon. So that'll be 10 times 57.603, which will give me a total area of 576.03 square units. All right. The only last thing we have to cover is what do you do if you don't have an angle? Because you have to have at least one angle and two sides in order for this to work. So what if you don't have any angles at all? Then what do you do? And that's the very last thing we're going to talk about. All right, that's our final, bless you, formula for the chapter. This is called Huron's formula. And it uses no angles. So it doesn't matter if it's a right triangle or an oblique triangle. It doesn't use the angles at all. So it doesn't matter if it's 90 degrees or not 90 degrees. It only uses the sides. Okay, and here is Huron's formula. There's a whole big, he figured this out with a whole big long proof. I'm just going to tell you what he figured out. Okay, it's a really long square root, but that's okay. You can let your calculator just figure it out for you. The letter S times the letter S minus A times the letter S minus B times the letter S minus C. So what's your question? What's S? Okay. S is what's called the semi-perimeter. Do you guys know what the perimeter of something is? Right? Perimeter is add up all the sides. Okay, what's semi-perimeter then? Half of that. Okay, so the semi-perimeter is S. So you add up all the sides, A plus B plus C, that's the perimeter, and then divide it by 2. So you figure that out first, and you have A, and you have B, and you have C, and then you can use Huron's formula to find the area if you don't have any angles at all. So we'll do one of those, and then we'll be finished, and the bell will probably ring right as we're doing it. Okay, so suppose you have the parts of your triangle, A, B, C, but you have no angles at all. All you have is 43, 53, and 72. So you can't use the regular area formula because you don't have any angles. So you figure out the semi-perimeter, which means you take 43 and 53 and 72 and you divide it by 2, and that works out to be 84. When you do that on your calculator, put parentheses around all the pluses, because otherwise your calculator might give you the wrong answer will give you the wrong answer if you leave off the parentheses. Once you have the semi-perimeter, then you can type in the area. And so you start with 84, and then parentheses 84 minus 43, parentheses 84 minus 53, and parentheses 84 minus 72. All right, I know what the answer is.